Hello, I am Professor Collins, and welcome to the Excel workshop. So today we're going to be going over single sample t-test. This is also known as the one sample t-test, and that's because you're comparing a single sample or one sample to a larger population. And so let's just go over quickly the objectives of the workshop today. So our main objective here is to calculate and interpret the single sample t-test with using Excel. And so just real quick, let's go over this. I assume you know these things, but I just want to go over these real quick. So using the single sample t-test, there's two purposes to use the single sample t. First is to test the mean difference the mean differences in a sample mean versus a population mean for some continuous dependent variable, right? The second use of a single sample t-test is to test your sample mean versus some hypothesized score, right, for a continuous variable. So what you're doing in this case is you're coming up with some hypothesized score for whatever reason that may be, and you're testing against that hypothesized score. For the workshop today, we'll just be doing this first one. So your steps here to calculate a single sample t. First, state your assumptions. These are going to be normal for all t-tests, as well as an ANOVA, analysis of variance. State your hypothesis, null and research hypothesis. Establish your critical region. Compute your test statistic, and that's really what we're going to be doing today, and interpreting your results. So now let's jump into the data. So let's just take a look at this data real quick. So let's sort of focus right here, and I'll zoom in a little bit so we can see this, and then I'll zoom back out. So what we're looking at here is, let's say I'm interested in passing yards, right? And so I'm a big National Football League fan, and I'm a big football fan generally, right? And so let's say we're interested in passing yards. And let's say my favorite player is Russell Wilson. So now we have our dependent variable, which is passing yards per game, right? Quarterback passing yards. This is a continuous variable, and this does not have a range, actually, so I'm going to remove that. And so this is a continuous variable, right? And so let's zip out here a little bit. And so our research question here is, does Russell Wilson throw more passing yards per game than the average NFL quarterback? And as you can see here, I've calculated already the average passing yards per game for NFL quarterbacks, and it's 238.86 yards. So let's go through our steps. First, again, these are going to be standard. Random sampling, continuous dependent variable, and a normal distribution. And let's state our null and research hypotheses. So these null and research hypotheses and the critical region are going to flow directly from the research question, right? And so our null hypothesis is that Russell Wilson's yards per game are less than or equal to 238.86, right? The average for NFL quarterbacks. Our research question is the opposite of that. Russell Wilson's yards per game are greater than 238.86. And this greater than is important because this is where it comes from, right? It's the way the question is stated. Does Russell Wilson throw more passing yards? This is much different than if I were to say, is Russell Wilson's average yards per game different than the average NFL quarterback, right? Different doesn't indicate a direction. More or less indicates a direction, right? And so that's why you have directional hypotheses here. Same thing with this critical region, so we have to establish this critical region. So we're going to do a one-tailed test because we're specifically stating more yards, right? So we're looking specifically at one side of the distribution. Our alpha level is going to be 0.05. This is fairly standard. Unless you want to be a little more conservative, then you could go to 0.01. And then our degrees of freedom, 16 minus 1 is 15. And then what you can do is look in your book in your appendix for your critical region. All stats books will have this. The cool thing about Excel, however, is that Excel will give us this, so we don't need to compute it ourselves, or I should say find it ourselves. Now what we're going to do is we're going to compute our test statistic, and so that's the big thing that we're looking for here. And Excel's a little funky. Excel does not actually have a one sample test, so we have to kind of trick the program a little bit. So what we have to do is actually do in Excel what is a two-tailed test, or not a two-sample test, meaning in order to do this we have to actually have two variables. So what we're going to do is we're going to drag this down so that we now have two variables, right? So instead of just having the average here, we now have the average for all 16 games. And you notice, of course, it's the same average, right? There's no variation here. So what we're going to do is we're going to go to our data, and we're going to go open our data analysis tool pack. If you don't have this, go online. There's various demonstrations on how to open yours. And so what we want to do is click on this t-test two sample assuming unequal variances. Click OK. And so we have our first, right? So what we want to do is make sure we have our first variable. So we'll highlight that column, and our second variable. So we'll highlight that column. And we have our labels here, so we want to keep these, and we want to keep our alpha level at 0.05. That corresponds again to that critical region. And we'll put this in a new workbook, and we'll call this results without a K. Alright, and we can go ahead and click OK. And we have our data in our results section. So let's kind of just open this up a little bit and take a little bit better look at it. So what you can see here is that, again, there's no variance for yards per game. It's very, very tiny. Should be 0, actually. We have our average yards per game. We have our observations, and we have our mean for Russell Wilson's passing yards per game, right? And as you can see, Russell Wilson is a little bit smaller. And so asking the question, is he's greater, this already tells us no, he's not greater. But let's see if he's significantly less than the average. So what you can see here is we have our t statistic. And so this is the statistics you're going to be comparing, right? So let's go back to our raw data here so we can just sort of, what I'm going to do here is steal this and bring it over to our results section. Actually, I'll steal both of these and bring them over to our results section so we can see them. So let's plug these into our results section. So as you can see here, our critical region has been identified, right? Our T critical one tail, because we're doing a one tail test. So we don't need either of these two columns. So we can actually, or rows, excuse me, so I'll actually just black those out so that we can't see them because we don't need them. So we do need these. These are the three main pieces that we're going to be looking at. So I'll highlight these green, right? So what we have here is our test statistic. We find equals negative test stat equals negative 1.5, let's round up to 7. And what we're doing is we're going to compare this test statistic to our critical region and ask the question, is the test statistic in absolute terms, is it greater than the critical region? So the question here is 1.57 greater than 1.75? And clearly the answer is no. The cool thing about that, though, is this tells us, this is essentially our alpha level for our sample mean, right? And so if this is less than 0.05, so I'll highlight this a different color, I'll do this orange. If this is less than 0.05, then we reject the null hypothesis, right? Or to put it a different way, if this is less than 0.05, we accept the research hypothesis. So based on that, we can interpret our results. So we reject the null, or no, excuse me. We reject the research hypothesis, accept the null, and we can interpret this by saying something like one sample t-test that Russell Wilson does not throw for more yards per game compared to the NFL average, right? And so we don't have support for our research question, right, or our hypothesis here. So in this case, we're rejecting the null hypothesis. We're rejecting the research hypothesis. So that's the way you run a one-sample t-test in Excel. So let's go back here and just make sure we've covered everything. So now you should know how to calculate and at least have some idea about how to interpret the single sample t-test in Excel. Thank you for watching.